Hi everyone, I'm Bronson Zgeb, a content developer at Unity. In this session, I'll be covering some of the different ways you can save your game states and settings in Unity. So let's get started. In today's session, we're going to start with a quick overview and demonstration of Unity's PlayerPrefs. This isn't recommended to use for any serious data, so we're going to show when you could use this and why you'd want to upgrade to a more advanced option. After that, we're going to see a brief overview of JSON, including its strengths and weaknesses. This will set the stage to talk about Unity's built-in JSON utility, which allows us to save and load our data in the JSON format. In this section, I'm going to show you how to get started with JSON utility, followed by how you can architect your data for more complex use cases. After we've explored the built-in options, we'll suggest some powerful external libraries that you could also use. I'll show you why these options may suit your particular use case better than the built-in options. Then, when we're done talking about data serialization, we're going to touch on the topic of data security. So let me just show you what this looks like in practice. So right now, every time that I reload the game, my score will get reset to 0. Now let's say you just wanted a quick and dirty way to save your score between runs of the game. For that, we could use PlayerPrefs. I have a little game preferences manager here with a way to save my preferences and load my preferences. All you really need to do to save is pass in a string. This will be an identifier for storing and retrieving your prefs, and some kind of value. So we're using setInt, so we're going to pass in an int, and this will set our score to 5. In order to load the score, we need to give it the same string and a default value. So if it doesn't find something in PlayerPrefs under this string, it's going to return this instead. That's going to go into our score, and we're just going to set that to our game manager's current score, but you could set it wherever you need. And because we're reusing the same string in two places, I've created a string called score key, and I'm just going to use that instead. And we don't really want to just set 5 every time. So we're going to get our score from our game manager instead. Whoops. So now we'll be saving our current score from the game manager under a string called score. And then to load the prefs, we'll check the string called score. If there's nothing there, we'll return 0, put that in our score, pass that back to our game manager. Now if I kill this guy, my score goes to 10, and if I reload, my score is still 10. So on Windows, the PlayerPrefs get stored into the registry, and I can show that here. So right now, here's our score, and you can see that it has a value of 10. And if you wanted to, you could just set it to 100. Restart the game. Now your score is 100. And you might just delete that. Or maybe, who knows, it could get deleted by the OS, I don't know. And now our score is gone. So let's say you just wanted a quick and dirty way to just save some data. For that, you can use PlayerPrefs, but it's not recommended. PlayerPrefs is the quickest and easiest way to save data between runs of your game. The way it does it is by storing simple data types to a file stored on your device. The files are easy to find, read, and modify with a text editor. So not only is this bad for security, but it also means the data within is prone to being lost or corrupted. So it's important to take that into account. For these reasons, it's recommended that you use PlayerPrefs to store data that you can afford to lose. It's really meant to store things like a player's preferences, for example, graphic settings or audio levels, things like that, or it could be used as a temporary save solution, I guess, while your project's still in development. Another drawback of the PlayerPrefs system is that it's harder to serialize complex objects, so the API only supports storing floats, ints, and strings. In theory, you could pack anything into one of those types, but you'll have to maintain a system to convert between those types in your in-game data types. It's also very difficult to support multiple saves using PlayerPrefs, and ultimately, it's just not made for saving your game states. So we're going to move on to another option. Here's just a little example to show how little code it could take to save to your PlayerPrefs. And now I'm going to show you JSONUtility in action. Let's say that we wanted to save our score using JSONUtility instead of PlayerPrefs. We're going to remove the code that we were using for PlayerPrefs. I've created a save data class, and it just has one field for our score, and it has two methods. One to convert this class to a JSON string, and one to take a JSON string and fill like this class in. So in our case, it would fill in the score. I also created an interface iSaveable with two things. One is to populate save data, and another to load from save data. So the idea here is anything that has data that you would want to save, you would inherit from iSaveable, and then have a function populate save data that takes an instance of this class and then fills it with whatever data that wants to save. And then when you load, you take an instance of this class and then pull out any data that you wanted to load from it. Now, in this particular case, this is a little bit overkill just for the score, but I made it to help us in the future with our more complex use cases. So if I go to our game manager here, I'm gonna quickly inherit from the iSaveable. I have a function here to save JSON data and a function to load from JSON data. So we could just do this and not have a populate save data function. But just to support what we're going to do in the future, I'm going to make it just a little more complicated and keep our populate save data. So basically, how this works is when we want to save our JSON data, we create a new instance of the save data class. We ask our game manager to populate it, which just means, in this case, taking the current score, putting it in the save data. And then we write that to a file that I'm calling savedata.dat. And then in order to load, we read the file savedata.dat and take the contents, put it into this JSON string. Then we create a new instance of the save data class. We ask it to load from our JSON string, and then pass that save data class, which now has our score in it, into the game manager, and then the game manager will set the current score to whatever was stored in the save data class. So now our score starts at 0 again. If I quit, start again, it'll be 20. And we can see our save data right here. So this is a JSON string. It has one field, score, and a value. And we can make that value 200 if we want. And boom, now our score is set to 200. But we have a problem here where every time we reload the game, we keep our score, but we don't keep track of all the enemies that have been killed. So I could just keep doing this and gaining score forever. So what we need to do is also keep track of enemy data. So for that, I'm going to also inherit from iSaveable for enemies. I'm going to add a list of enemy data to our save data class, and I'm going to create a new struct of enemy data. So each enemy in our game is going to save into an instance of this enemy data, and what it's going to store is a unique identifier. This is something that I've tagged every enemy in the game with already, and it's going to store the current health value. And then we're going to keep a list of these enemy data, and then in order to populate and load from our save data, I'm going to go into the enemy class. So to populate save data, I pass in an instance, whatever our chunk of save data is. I create a new enemy data for this enemy. I fill its health with the enemy's current health. I specify the unique identifier with this current unique identifier, and then I just add it to my enemy data list. That's this list. And then to load, I'm going to also get an instance of the save data class. I'm going to iterate through this list. And if I find one piece of enemy data that has the same identifier as this enemy, then I'm going to take its health and set it to my current health. And if that current health is less than or equal to 0, I'm just going to ask the game manager to destroy this enemy. So we just have to do one more thing to support this. We have to ask our game manager to actually save this. So when I'm populating my save data, right now it's just filling the score. I'm going to add this, where the game manager is going to go through a list of every enemy in the game, and for each of those enemies, it's going to ask it to fill our save data with that enemy's information. When I'm loading, I'm just going to go through and do the exact same thing. Go through all the enemies in the game and ask each one to load itself from the save data. But now we're going to see we do have one more problem. The enemies are still respawning. Why is that? Because every time an enemy gets killed, it actually gets destroyed. So it's no longer in our list of enemies. So this list of enemies is not going to have any of the destroyed enemies. So the ones that are destroyed aren't actually going to get saved. So I did one more thing. I keep a list of all of the destroyed enemies' unique identifiers. And when I save, I'm also going to go through that list. And for each of those, I'm also going to create a new enemy data. I'm going to set the health to 0 because the enemy is dead. And I'm going to set the unique identifier, and I'm going to add that to the same list of enemy data here. And now you'll see that the enemies are dead. Great. We can take a look at what that looks like. So now we have one field for our score, another field that's just a list of enemies with first their unique identifier and then their current health. And if we wanted to support, let's say, multiple save files, I'll show you one last thing. Right now, I'm just writing to a file, savedata.dat. If I wanted to write to a different save file, I might say, I don't know, savedata01.dat. And now I have a brand new save, score of 0, the enemies are here. If I load, score of 20, the enemies are gone. We can see this is my save data folder. It has 3 different saves in it. So if we wanted to support multiple save files, we would just need to iterate through our save data folder, find all the pieces of save data, and then show that to the user. So let's talk about the JSON format and what problem does JSON solve. Some games use binary files to save their data. One of the problems you encounter with binary files is that they aren't human readable. Similarly to PlayerPrefs, JSON is human readable, and this is valuable when you're testing or debugging save files. Next up, JSON is a widely used format. So let's say we wanted to store our player data on a server. If we don't use a widely accepted format, we can encounter issues doing that. On that note, JSON is a fairly compact file format, which also makes it ideal for passing over a network because smaller files means faster transmission. And if we wanted to support multiple save files or cloud saves, it's much harder to do that using PlayerPrefs. So using JSON allows us to easily save and load from multiple save files. And what if we want a more robust way to save our data? We use Unity's built-in JSON utility. JSON utility is Unity's API for serializing and deserializing JSON data. By the way, serialization is just the process of converting data so it can be stored to a file. JSON utility is simple to implement, but unlike PlayerPrefs, you'll have to store the data yourself. But this can be an advantage because it allows you to easily support multiple saves. It also allows you to get your data from anywhere, such as through a network or something. Any data that Unity's internal serializer can save and load can also be saved and loaded through the JSON utility API. This basically means that only the fields that you see in the inspector will get converted to JSON. JSON utility is constrained to the same limitations as the internal serializer because they're both using the same system behind the scenes. When you pass an object to JSON utility, it'll ignore any unsupported fields. This means you'll likely have to make new data types to contain your save data and write code to convert between your save data and your in-game data. So here's an example of JSON utility in action. All you need to do to convert a class to JSON is pass it to the JSON utility. Then, when you want to get your object back from JSON, you pass a JSON string and an instance of the object you want to fill. But as I mentioned before, it's on you to store your JSON somewhere. So for that, I wrote a basic file manager. I'll just run through this very quickly. This is a pretty standard function for writing a string to a file. The only thing I want to highlight on this page is the use of Unity's persistent data path. Unity has a handful of built-in data paths in the application class, and you can use these to read and write files. Each path supports a different use case. So in our case, I'm using the persistent data path because that's where you want to store persistent data. Here's a standard function to read back an entire file. It's more or less identical to the last function, but we're reading instead of writing. So before we move on to security, I want to discuss some other alternatives. What if you just want an easy solution to handle this all for you and you're willing to pay for it? For that, I would suggest using EasySave. EasySave is easy to use, and it's a fully featured save and load system available on the asset store. It's flexible, but also powerful. It can be used to save even without writing any code, so it's a great option for both beginners and professionals. What if you're looking for a fully featured JSON serializer and deserializer, so something that's not limited by Unity's serialization restrictions? Well, JSON.NET is a fully featured JSON serializer. It may help reduce the amount of code you have to write to move your data from in-game types to their saved data classes and back. It's available for free on the asset store. And if you don't like JSON or you prefer XML because you need some of its specific features or something, XML is an alternative data format to JSON. It's also relatively human readable. Sometimes it can be a bit more verbose than JSON. It supports structured data and namespaces, which might be valuable in your particular use case. And .NET has built-in support for handling XML data, so that's another option you could use. Now I'm going to discuss data security. So what if you want to protect your data from being tampered with? The first thing that most people think of when it comes to security is encryption. However, encrypted local data isn't hard to overcome. It's really just a deterrent used to stop your least dedicated players. So as a general rule, it's safe to assume that any data that's stored locally is untrustworthy. It's important to consider data security as early as possible because it'll affect the way you architect your project. If a player cheats in a free-to-play game, it could destabilize your game's economy, whereas there's little harm to others if they cheat in a premium single-player game. So how do you truly secure your save data if you need to? Well, if security is important to you, your best bet is to keep your data on a server rather than locally. Since you can't trust anything the game client says, you'll want to structure your project so the client can only send commands to the server rather than actual data. Then the server can decide whether the command is valid and send back only the result. So for example, if your game uses loot boxes, rather than storing the loot boxes on the client, what you would do is store them on the server and have the client send a command to open a loot box to the server. The server will check if that's valid, do all the work, open the loot box, and then tell the client what was inside without actually storing any real data on the client. So to wrap up, we've learned that PlayerPrefs are easy to use, but best for data that you can afford to lose. This is usually things like player settings or preferences. JSONUtility is Unity's built-in JSON serializer, which is a robust way to store your serious data, such as your game state. Finally, security is something that should be considered from the start. Encryption is just a deterrent and not real security. So for real security, you have to store your data on a server outside your app and architect your project around these constraints. If you want to learn more about Unity's serializer, you can read about it in the Unity manual. I've provided a link to these slides and the Unity manual below. Thanks for attending this Unite Now session on persistent data. I hope you've learned a lot. Feel free to provide us with feedback. Finally, be sure to check out our Unite Now page for other sessions that are sure to inform and inspire you.